We have a question from Nell, which I think is honestly the crux of why we're all here tonight.
Hi, I've got a question for Mr. Science Man. If my bum got like real big, would it be able to its own gravitational force?
Oh my God, Becky, look at her butt.
Okay,
All right.
so how big would my ass need to be to have a real strong
All right.
gravitational pull?
Cool. Let's answer this question: is how big must your butt be for it to become a black hole?
In some cases.
In some cases, it's kind of already there. But let's talk about the scientific black hole.
This is 5 After Hours. I'm Leah Jazz, and I am joined by the one and only Dr. Luca Pontiggia, who is the head of technical communication at Discovery and holder of a PhD in theoretical physics. You founded this really cool thing called Universe on Stage, which is super cool. And you also are like a runner-up of Mr. South Africa. Okay, can you tell me what you don't do?
I don't sing and I don't play an instrument. So you can't ask me. That's off bounds.
All right, noted. All right, so tonight we are asking some stupid questions. And I think I'm going to go first if that's okay.
Go ahead.
Also, be warned, tonight we are absolutely putting the ass in astrophysics. Sorry, not sorry. My question is, if the universe is always expanding, what is it expanding into? I don't understand. Like, if the universe is the universe, how is it getting bigger?
You asked the one. That's a hard question. It's a very good question. It's not a silly question. It's actually a very profound question. And it leads us to asking the question, well, where did the universe come from? So if it expanded into something, did it originate from something? And that is a really hard question. I would say it's not really expanding into anything. That's, I think, how people usually talk about it. It's rather just spaces being created from within itself, and it is expanding from within itself outwards. So you have the fabric of space-time, which is itself expanding because there's more space-time being created within the space-time. And so that's kind of how it's like expanding within itself. Into what? I don't know. But that's how we think about it.
The more you speak, the more stupid I feel. All right, so Matt has a question for us. And it sounds like this.
So my question is, will we ever reach a point where we've got so many satellites orbiting Earth that it becomes too dangerous to launch any more new rockets out into space?
So that's a really good question. Right now, there are plenty of satellites that are existing outside of our planet. But remember, like, the atmosphere is extremely big. So you might have a couple thousand, I think, satellites existing, but they have so much space between them that it's actually really low density. So there's no risk right now in adding more satellites in terms of too many satellites coming into space. But the risk is that as we add more satellites, if something happens to them, they break out into 1,000 pieces.
And
so
then
one satellite becomes 1,000 mini little satellites, bullets orbiting the Earth. And that is where the problem comes in.
Because if you launch a rocket and it hits like a little tiny chip.
Boom, gone.
Really?
Yes.
Really?
Yo, you have a little chip, like this, a marble, that's moving at 8 meters per second, or potentially even faster than that.
8 meters per second.
Yeah, or even faster than that. Don't quote me. But it's really fast.
Is that fast? 8 meters per second. Is that like a cheetah speed?
That's actually quite slow now that I think about it. It's like it's slower than a cheetah. So that's
80
probably not the right thing. It's probably 8 kilometers per second.
Okay.
Maybe that's the right one. Because they're going so fast that even a small little marble has enough energy to puncture the outer shell of some spaceship or satellite. And that'll create on this chain reaction of many more different fragments, creating more fragments. And all of a sudden, then you're going to have a complete shell of fragments around the Earth, which won't let any other satellite go through. So it's sort of this not necessarily exponential risk, but the more satellites we put into Earth or into the atmosphere of Earth, the greater the risk of a single shattering event creating a cascade of more shattering events.
Hello. Okay, so what happens if two black holes try and hold hands?
I find that quite a cute question. I mean, obviously black holes can't hold hands.
Because they don't have hands.
They don't have hands.
How do you know that they don't have hands?
Actually, wait. There's a thing called no hair theorem, which they say black holes have no hair, but it's a whole different story.
Wait, why would I need to know that black holes don't have hair?
It just reminded me of the hand, like a hand's appendage is part of the human body, and then I just thought hair is part of the body as well. So that's just the link that my brain made.
Okay.
But anyway, so.
Okay, what if they tried to kiss then?
Okay. Firstly, what is a black hole? A black hole is an object that doesn't allow any light to escape if it comes into the vicinity. So you can think of it as like a shadowy boundary. Shadowy boundary that doesn't actually have a surface, but it has a point of no return. So as if you're going into a dark room, you pass that threshold, boom, you're in this dark room, right? You can't touch the darkness, but you're just in it. So imagine a black sphere, which is like a shadowy sphere moving in space. You have two shadowy spheres moving in space. They get closer and closer and closer. And by kissing or by having their hands touch, what you're saying is that the event horizons of the two spheres are crossing each other or touching. When that happens, I don't actually know what happens at that exact moment, but the progression of what will happen over time is these two black holes will merge. They actually combine. They kiss together until their faces become one big face.
One giant
One
face.
giant mouth. I don't know.
Well, yeah. Do we think about black holes as like a mouth? Like a...
It's kind of like a good analogy to sort of say like they're sucking in light. It's obviously the right way of thinking about it, but it's that the idea that anything which gets too close gets trapped inside behind it. I like using the analogy of a giant mouth inhaling the very rays of light as a, let's call it, poetic form of describing what a black hole is. But in reality, it's not really that.
We had another question from Lauren who wants to know, how worried should I be about the spaghetti thing happening to me?
So spaghettification, a genuinely real term when it comes to physics terms.
Yeah.
It's the process by which when you fall into a black hole, right? So you pass the event horizon. Now, once you're inside the black hole, you can't really escape, and you keep moving towards the center, the singularity. The differential gravity pull between your legs and your head becomes so strong that you actually are pulled apart. And as you move forwards towards singularity, you are extruded from each side, as if you're like going through a cosmic funnel. And your atoms are quite literally ripped apart, and they are flung into one long sort of speed of atoms, hence spaghettification, like a long spaghetti of atoms going towards the singularity.
Now, I don't actually know what dark matter is, but Martin has a question about it because I don't think he knows either.
Hello, astrophysicist. Is dark matter a solid, liquid, or gas? If a liquid, would it make good lube?
Nice.
And look, I did say that it was all about stupid questions, so take it
Okay,
away.
so he's asking about dark matter. First of all, let's just say, what is dark matter? All right, what is it?
I don't know. That's why I asked you.
The way we describe matter is how it interacts with stuff in the universe, right? So, for example, a solid interacts with solids in a very particular way. A gas will interact with a gas, light interacts with gas, things interact with each other, okay? Now, dark matter is some matter, but it does not interact with light. So the electromagnetic spectrum, waves. Meaning if like a pane of glass, when light goes through it, it's transparent. We can't see the glass. Imagine you had perfect glass. We wouldn't know it exists until we touch it. We can feel it, right? Because also touching essentially is actually just electromagnetic forces that stop us from being able to go through something. So the point is, dark matter does not interact with anything normal matter through light. So it is invisible to us, hence it's dark. But it interacts with gravity, and we can see it's a gravitational effect. So I can't say that it is a gas, matter, or liquid because we don't know what phase it is in terms of its existence. Or we know that it has enough mass that it creates gravitational interactions with normal matter.
We have a question from Nell, which I think is honestly the crux of why we're all here tonight.
Hi, I've got a question for Mr. Science Man. If my bum got like real big, would it be able to its own gravitational force, theoretically speaking?
So how big would Nell's ass need to be to have its own gravitational pull?
Oh my God, Becky, look at her butt.
I like this. Actually, it already has a gravitational pull. Any object that has mass has a gravitational pull. It's just very, very weak.
Okay,
All right.
so how big would my ass need to be to have a real strong
All right.
gravitational pull?
Cool. Let's answer this question as how big must your butt be for it to become a black hole?
In some cases.
In some cases, it's kind of already there. But let's talk about the scientific black hole.
Okay.
Okay. So basically, you would need a butt. Either two things. So anything can become a black hole if it is big enough or heavy enough.
Okay.
Right. So either you need a butt the size of the solar system, and then it will spontaneously become a black hole. but a butt that is made of the usual density of your normal butt, right?
Yeah. Carry on.
Or you need a butt which is about the mass of 17 Earths. And if your butt, the current size, about 15 centimeters or more,
was that just an
just a
official
random-
estimation?
I don't know.
15 centimeters of ass, everybody.
Okay.
Okay.
It's the standard metric of ass size, you know. If it was the mass of about 17 Earths, it would spontaneously become a black hole.
17
Yeah,
Earths.
Yeah. So anything between your current size and 17 Earths, you would have a pretty strong gravitational pull.
Wow. Make sure you drink your protein powder
I like
because
big butts and I cannot lie. You other brothers can't deny. Yeah, when a girl walks in with an itty bitty waist and a round thing in your face, you get sprung.
this was Dr. Luca Pontiggia answering your stupid questions on 5 After Hours. Thank you so much for hanging out with us tonight.
Thanks for having me.